Hey, good afternoon everybody, and welcome back to the channel. Lots of rain today off and on, and enough solar coming in to keep everything charged up. So once again, best of both worlds, water and sunshine. And today we've got a new 12-volt inverter to look at. And it says it's a 3,000 watt pure sine wave inverter. And this is from a company called TOPBULL. Pretty nice looking inverter. Got a couple of nice beefy mounting terminals there. Couple of fans on this end. Yeah, it's got a USB-A and a USB-C type terminal there. Couple of AC outlets. You got a connection port here for a remote control switch, which it did come with, and I'll show you that. On-off switch, and then a display there. And this is what it came with. It came with a couple of sets of some cables here. These are both 10-AUG cables. Came with your remote control switch, which looks to be fairly lengthy. We'll see how long that is when we undo it. And then a dozen 30 amp fuses that hopefully you won't need, but it supplied those in case you do. 12 volt DC, 110 volt AC. The entire case is a very solid feeling structure. Yeah. And in the back it has 4 mounting brackets already assembled to the case. Top and bottom, for however you'd want to mount this unit. And of course it did come with a user's manual. Okay, so let's get this all hooked up to a battery and see what it can do. Now, if I was going to mount this and be using it for all household use, I would quickly discard these 10 gauge cables and get something much heavier. I'm not going to try and pull 3,000 watts off of these, but since they do send these out, we will give them a tryout, and they do recommend using both sets, and I'm sure it will pull some good power. But again, if you were going to be pulling anywhere near 3,000 watts, you'd want to beef up those cables. But this is what they've sent, so we're going to use it. And in this situation, we're going to imagine that my refrigerator here has run out of power, is not working, or has nothing going into it, and we're going to show how quickly you could use something like this to get back up and running and keep your food good. So we've got a battery that's been sitting here. This is a 300 amp hour lithium iron phosphate battery. Been sitting for months without a charge or discharge. We'll see what that's reading at, see how the display reads it once we hook it up. So I'm going to get this tied up and we'll go from there. Only going to need 2 different size sockets, a 13 and a 14 millimeter socket, to get this whole project underway. And I just tested this on the multimeter. The battery reads 13.24 volts, and then when we hook up the inverter, we'll see what it reads. So I really do like these cable terminals here. You know, they have nice protection all the way around, so you just loosen the top part there, comes right off very easily, and then this slips right off, so you have great protection around all of the metal part of the terminal there. So once you get the cables tied in, slip the cover back on, put that nut back on there, tighten it down, and you've got really nice protection. And this is very, very sturdy. I like that. So same thing on this one. Just undo it, slip this right off, and we're ready to tie in some cables. Okay, and looking at the two sets of cables, there's no way to mount the two sets and have them make contact, so I'm just going to assume that they sent an extra set, because the only way you could get those to fit would be to turn them sideways like that, and you could make contact, but then the cover will not work on this. So I'm just going to assume that they sent an extra set, and we're just going to hook up one of each and go from there. But like I said again, these are not the type of cables I would use other than in just a very temporary situation and for like what I'm going to demonstrate today. Okay, we got the cables hooked up. I do like these covers for sure. That's a nice thing to see. Not all inverters do supply you with that, but we're ready to go and turn this on. Okay, inverter tied up to the battery. We've got the remote control switch put on there with its probably 20 feet of cable. I haven't stretched that out yet, but let's give this a push and see what happens. It's in the off position, so we'll see if it works being in the off position or if that has to be on and then it works. But anyway, it's inverter off. Let's give it a push. And it turned on. Very good. Let's see what it reads here. Got a startup motor going for the fans. Hopefully it kicks off, because I wouldn't want to hear that all the time. So yeah, that's just the startup. It's showing the battery display as full. It shows 12.8 volts, which is the nominal voltage of the battery. And see if you can see right there, 16 degrees Celsius. It gives a pure sine wave icon to the left of that and reading at 111 volts. So yeah, pretty nice little display. That's good to see. And those AC outs are, you know, kind of upside down at this angle, so for me to, I can't plug in my watt meter like this. I'll have to turn it upside down to make it fit, which is not a big deal. And then I'll just turn the inverter on the side. Well, scratch that. I'll just leave it like it is so we can kind of see hopefully what that display says. But anyway, here we go. We're going to plug in that refrigerator freezer right now. This is a 20 cubic foot LG inverter compressor type refrigerator freezer, and we should see here, I'll have to tell you, it's upside down, a little inconvenient, but sometimes things are. Pulling 249 watts right now, and that's because when I disconnect this refrigerator freezer, it assumes there's been a power outage. So when I unplugged it, it immediately, upon plugging it back in, kicks on the auto defrost, and that's why it's pulling that. Otherwise, in a normal cycle, this thing just draws about 50 to 60 watts, or I'll say 50 to 80 depending on what the ambient temperature is. But anyway, and let's see if we can read what's going on back there. So the display shows 189 watts, 110 volts, reading the battery voltage now at 12.6, and yeah, everything looks pretty good. So it's running. The fan has not kicked on, pulling the 250 watts. Yeah, rock steady 249. As you can see, that's upside down. Okay, I'll see if that fan kicks on, but it's not right now. I'll just check and see if there's any heat on those. I wouldn't expect them on that, but again, I would not attempt to pull 3,000 watts through these 10 gauge wires. I mean, they're very, very, you know, very, very small. It should do fine for this. So I'll come back in a minute. Usually this auto defrost runs for about 20 minutes. Then it'll go back into kind of a normal operation. Probably kick on to about 60 watts. And here I am standing, oh, at least 20 feet away with the remote in my hand. So you do have some flexibility with this remote, which is nice. You can run it quite a ways away from the inverter. Got it strung out here as well as with the extension cord for the refrigerator, which again, it's this one right here. And it's running in auto defrost, which is the highest amount of wattage this thing pulls is when it's in that mode. And everything's just looking good. So I like having an inverter like this, just kind of in this type of a scenario where you've got a, you know, quick backup system you can deploy. Now I would put a fuse normally between the positive and the inverter somewhere. Off the battery is generally where I like to put one, but just for today's test we're not using one. Sitting here watching everything like a hawk. But I do like having this kind of a system where you can just pull out your spare battery, bring out your spare inverter, and you've got your power back on where you need it. So I like this. Now if I was going to tie this up to permanent use, you know, I would use, of course, different cables and some other breakers and switches and whatnot like I do on all my other systems. But yeah, for something like this, that's a pretty handy little system you can roll into action if you need be. Yeah, and besides your refrigerator running, you got to make a cup of coffee, of course. Yeah, bumped it up to 300 watts real quick, no problem there. Still running the refrigerator, got coffee grounds ready. Turn on your coffee maker. Light is on. Quickly kicks it up to, let's see, 792 watts. Easily within the range of its capability. Coffee maker running, dripping hot coffee. 789 watts. Let's see if we get any. Yeah, those little 10 gauge are still cool to the touch. Haven't kicked on the fan yet. No problem. 789 watts is all we're pulling. But yeah, pretty nice little thing to have on the fly for whatever you need. You got to pull some food out of your fridge and you got to have a cup of coffee. Yeah, I like stuff like this for, you know, can cart this around on a little hand truck anywhere on the property I need. If I need to pump some water, easily will move some water. I've got a little sub pump that will pump water for hundreds of feet if need be when I'm transferring water around. Something like this will easily handle that. So very portable. I kind of like it for that. Although I think this would be just fine in a permanent situation as well. Just change the cables. Yeah, it's doing well though. Don't see any problems. Fan is not even kicked on one time. Pulling pretty much 800 watts, 790. Coffee's almost ready. So yeah, other inverters that I use out here came with similar type cables as the TOPBULL sent, but you know, I replaced them with heavier gauge when I hooked it up to my systems, and I wouldn't be afraid to do that with that TOPBULL either. Just get some other components tied in, put some heavier cables in there, and you could use it for all your household use. I don't see any problem. But for my purposes out here, I like the little hand truck idea and moving this around anywhere I need power, and you got plenty. You run a skill saw off of that, I'm sure, no problem. Taking a quick peek at their website at TOPBULLshop.com. They want $300 for this unit right now. Not terrible at all for a 3,000 watt pure sine wave inverter. I think that's a pretty good price. And we'll just read over their 7 layers of protection: overload protection, short circuit protection, overheating protection, reverse polarity protection, leakage protection, under voltage protection, and over voltage protection. So some nice features there. And although we used lithium iron phosphate today, of course, gel, flooded lead acid, AGM, SLD, you can use all different kinds of batteries. You don't have to use lithium, but that's what we like. Oh, I just came running in here. The fan did kick on after about 30 minutes, 20 minutes of running at 250 watts within that defrost cycle. It only ran for just maybe 10 or 15 seconds, and then it was done. Nothing's warm at all, but not a huge load on it. That's one of the things about living off grid. I don't even think I own anything that'll pull 3,000 watts. And that brings up a point. I mean, when I have a 3,000 watt inverter, I don't really ever try to max it out at 3,000 watts. I have seen other reviews where they have done that. This has held up absolutely fine. The wires did get a little hot during some of those tests that other guys were running, as I would expect. But yeah, I've got a couple of other 3,000 watt inverters that I don't try to max out, and I wouldn't do that with this one either, but when you need a boost, you've got it. Okay, and just to finish up, the refrigerator freezer is now running in a cooling cycle. That auto defrost has long been over. The inverter shows 76 watts and my watt meter shows 72, but that's you know, the inverter power plus the refrigerator is what this is reading. So this all looks good, accurate. And that's the 4 watt differences. This is on the other side. This is just the refrigerator right here at 72 watts. So, and I will say that it did just kick on the fan one more time while it was pulling about 80 watts for a while, cooling off that refrigerator after that decycle or defrost cycle. And everything was absolutely cool to the touch. I felt no heat whatsoever from any of these, but we haven't stressed it very hard. You'll be seeing this in the future. I like it. I'm going to be using it around here. It's a very rainy day outside, otherwise I'd pull it out there and fire up the skill saw, which is about the most powerful tool I have to give it a little bit more of a workout, but not today. But you'll see more of this. Like it pretty well. Nice budget inverter if you're interested. Hope to see more from TOPBULL. And thanks to TOPBULL for sending this out for a review. Pretty nice little unit. And thanks to all of you for tuning in as always. Man, I just missed the biggest downpour. It was coming down so hard just a few moments ago. Been doing that all day. Staying hunkered down. Aloha, everybody. Hope you're all well. All's good here.